Welcome back, YouTube. Today we've got a no-cool call for a Trane chiller at this construction management office. Reports are that the chiller is in alarm. They had to reset the alarm a few times last week. Have no idea what alarms were, and their way of resetting the alarm is to turn the main breaker off, leave it for a minute, turn it back on, cools for a little, and then trips back out. So we're pretty much starting fresh. Chiller is right there. It's an air-cooled Trane. So we're going to start with our first steps. You can see that our pump is running for the main water loop. We're going to check voltage and amperage. So at 230 volts, we're rated at 8 amps. 460, we're rated at 4 amps. So let's go ahead and verify what our supply voltage is. This is the motor starter. Get my leads. So you can see we're pulling 7.1 amps. So we should be in the 230 range on voltage. Let's check that and verify. L2 to L3, 210, L1 to L2, 210, L1 to L3, 210 volts. So we are within rated, not over amping. We appear to be moving water. I'm gonna assume that all our valves are open. Looks like we got a makeup water station up there. So we verified the pump is running. It's an older pump. You can hear the bearings a little, but it doesn't sound too bad. Looks like I can't grease the motor itself, but I may grease these bearings before we get out of here. So we'll get up on the roof, open the control panel, see if we're flashing any alarms, and then go from there. All right, up here on the roof, we got a Trane air-cooled CGAM model. We're currently running, I'm assuming they reset the breaker. About 50 entering, 46 leaving, so that's not bad. Shows we're flashing one alarm. That was at 9:04 this morning for circuit 2, low suction superheat. Just giving it a quick glance, one thing I noticed, and this might not have anything to do with it, but it's definitely going to be a problem. These coils are totally blocked up. All the way right there. So the ones on this side are not that bad. This is my circuit 1 running. So before anything, I'm going to pop these panels off. We're going to clean these coils. Troubleshooting when you've got dirty coils like this, it's pretty much a crapshoot. So let me get a hose strung up here. We'll pop these panels off, get this coil clean, set up our meters and check components and all that stuff, throw some gauges on, and then we'll see what it does. Look at that. No bueno. So yeah, guys, before you get too deep into troubleshooting, always check coil airflow. You can see this cottonwood is just caked on here. I'm actually gonna get like a brush or a coil fin tube and scrape that off first before I hit it with water. You can see we're totally surrounded by trees, so it makes sense that this gets plugged up like this. Let's get the water hose. I just wanted to show you all a better picture before and after before I clean these coils. Okay, we got the coils cleaned. One thing I like to do when you see cottonweed caked up like that is I like to brush it off first, or if you have the appropriately sized coil fin straightener, you can scrape it off like that. The reason being is a lot of times as soon as water hits that cottonweed, it'll kind of turn to mud and cake up really bad and be hard to get off. So I like to scrape the majority of it off first and then blow through with water, you know, both sides, inside and out. This coil on circuit 1 wasn't too bad, so I just gave it a surface rinse. Make sure I was angling down like this and not pushing straight through to kind of rinse off any surface dust that may have collected. I think what I'm gonna do is I'm gonna gauge up to my suction line on circuit 1 since it's running, and then I'll come around here and gauge up on my liquid line for circuit 1 and check my pressures and my subcooling and verify that one's running okay to begin with, and then we'll hop on to circuit 2. So I'm gonna put these top panels back on right here on both sides, and then pop off these bottom panels so I have better access to the compressor section. Okay guys, we are probed up on circuit 1. The compressors are rated at 39 amps. We're currently running both compressors. So we have 32 amps on one compressor and 32 amps on the other compressor. Okay, let's verify we have correct voltage. So L1 to L2, 210 volts, L2, L3, 210 volts, and L1, if I can get it in there, 210 volts. Other compressor, L1, L2, 210, L2, L3, 210, and L1, 210. Okay. Condenser fan motors are on VFDs. This is our circuit 2 compressor, which is currently locked out. We're gonna check the incoming voltage and make sure that we have 210 and we're not dummy tripped. It doesn't appear that we're tripped, but we'll go ahead and check either way. 210, 210, 210, 210, 210, and 210. So we have proper voltage going to the compressor. Of course, it's not on right now, so we don't know what is actually coming through. Let's go ahead and check the pressures. So this is my circuit 1, the top side right here, gauged up to the liquid line. Have my clamp right before the metering device. Both compressors running, and pressures look really, really good. 110 suction, around 384, 385 head. It is currently about 93 degrees outside ambient right now. It's going to get up to 102, but right now it's about 93. 12 superheat, 17 subcool. Looks like the metering device is doing its job, and it's running like a tank for circuit 1. So our alarm showing on this, as we showed in the beginning of the video, and I don't know if you'll be able to see this, probably not. It's for circuit 2, low suction superheat. There's a couple things that can do that. I know sometimes when circuit 2 calls, if only one compressor calls and it calls for the second one, but only one compressor is running, the EEV will open up assuming that the second compressor is running, and it can drop the suction superheat really low. Another thing could be a possible faulty pressure transducer or sensor of some sort. Also, the strainer going into the heat exchanger, if it's plugged, can cause low suction superheat issues. I'm not entirely sure that's the case, because typically if your strainer is plugged, you're going to be noticing a similar issue on both circuits, because both circuits are going to utilize that strainer. So I'm not going to pull the strainer just yet. We verified circuit 1 is running really good. So let me take the gauges off of circuit 1. We'll switch them over to circuit 2. I'll reset the alarm, verify we've got voltage on the load side of the contactor, check amp draws, monitor our pressures, and then go from there. All right, one compressor on the second stage kicked on. Verified I have 210 across all 3 legs, 120 at the coil. This compressor isn't calling for. I verified that by checking the coil voltage back there. Should be 120 volts. I've got 0 volts. This single compressor running right now, we're at 27.5 amps. VFD is running at 60 hertz, 6.2 amps. It's rated at 6.2, so 27.5, 30 on that leg, 28. Amps look good. Let's check the pressures real quick. So one compressor running, 340 head, 9 subcool, 21 superheat, 115 suction. That seems okay for now. We'll have to wait until the second compressor on this circuit 2 kicks on to get a total more accurate reading. Not dangerously low at this time being, but we'll have to wait till that other compressor kicks on to see how much our superheat drops. If I need to, I'll disable circuit 1 just so we can stage up circuit 2 and actually put like a real serious load on it. And check back in with y'all in a minute. Okay, what I did is I went to the settings and I put circuit 1 on run inhibit, or locked out these 2 compressors so I could stage up fully on my circuit 2. So I've got 34 amps on this compressor that wasn't running last time. 31 right there. 32. 34. We'll check voltage real quick. 209, 209, 209, proper voltage. Amps look good. Temperature is raised to about 95 degrees. .7. We're rated at 39 amps, like I said earlier. Both circuits running currently. Let me adjust this on measure quick. I'm going to set my outside ambient to 96 because it's always a few degrees hotter up on the roof. 400 head pressure, 11 subcooling, 136 suction pressure, 15.5 superheat. Our suction pressure raised up because I had the unit in stop. Our entering water temp right now is about 62 degrees. We have 56 leaving temperature. It's a pretty decent split. So on a chill water application, the higher your incoming or your entering water temperature is, the higher your suction pressure is going to be. So as your entering water temperature drops down, say to like 50, 48, 45, your suction pressure is going to drop. That's basically what controls the suction pressure, similar to how a blower motor controls the suction pressure on a package unit or a split system AC. So I'm going to continue to let this run, try to get down to the 40s, 48, somewhere like that on my entering and my leaving, and monitor our superheat and our pressures in general and make sure we're not pulling down low. Okay, I've let it run an extended amount of time just on circuit 2, compressor A and B. We're currently at 51 entering water temp, 46 leaving, with a set point of 45 degrees. Both compressors running. Still have good pressures and temperatures. 114 suction, 406, 405 head pressure, 14 subcooling, and anywhere from 12 to 13 degrees superheat. So I'm gonna go ahead and re-enable circuit 1, and we'll see if it affects this circuit 2 any. Okay, after enabling circuit 1, we staged up one compressor. We dropped a compressor on circuit 2. So, coming to check, running one compressor, we want to make sure that our EXV is still operating properly and modulating the superheat as needed. So we've dropped one compressor. We're still maintaining around a 10 degree superheat, which is good. What we don't want to see is the EXV thinking that it's still trying to run 2 circuits or getting stuck and flooding and not closing off or dampering down as it should, which would cause my superheat to drop. So far, it still looks good. 11.8. We're gonna let it continue to run until it hits set point and make sure our superheat stays in a suitable range. Like I said, we don't want to stage off a compressor and that EXV is stuck, which could cause our low suction superheat alarm that we originally had. When I got here, see, this is the tricky thing when you've got a customer that just resets a breaker anytime a chiller goes into alarm. We know for a fact that these coils were just totally plugged up. I mean, there was gonna be no airflow going through. I was surprised when I got here that our original alarm wasn't for some sort of high pressure safety opening up. I really hate when customers just reset like that and not wait until somebody gets out here to see what the original issue is. So we're gonna continue to let it run, make sure our superheat stays stable, like I said. It may be that, I know these older CGAM chillers had to have the software updated, and that I believe pertaining to the EXVs. I think there's a service bulletin that Trane sent out somewhere out there regarding that. I don't have my laptop with the tech view with me. One of the other techs at our company has that. So if everything stages up and down like it should, I might leave the call open and have him come back or meet me out here, and we'll hook up the laptop and make sure our software is updated. That could potentially affect the EXV. Like I said, I didn't pull the strainer only because we have 2 circuits on this system, and if our strainer's plugged, we're probably gonna see that issue on both circuits, not just one. So we'll let it run and see what it does. Okay guys, so nothing alarming. Chiller ran to set point, 44.8, leaving water. We dropped out our circuit 2 compressor that was running. The superheat in a tank stayed stable the whole time, so I'm not too concerned with that alarm at this time. I'm gonna leave the call open for the time being. We'll come back out, make sure the software is up to date with the laptop, and we may even schedule some off time whenever this building isn't open, and we'll pull and check this strainer right here. And there's also a strainer down below where the pump is. We'll turn the chiller off, stop it, turn off the pump, close the isolation valves on the inlet and outlet line by the pump, and pull and check both strainers. Other than that, I'm not seeing anything super alarming, and it's not recreating any low suction superheat issue. So I'm gonna let it stage back up and watch it one more time. And if the issue doesn't persist or there's no other issue, I'm gonna pretty much call it at the time being. Like I said, we'll leave the call open come back and check the software, and then come back at a later time when we can actually shut the chiller down and it's not going to be super critical, and check the strainers. Any questions or comments, leave them down in the comment section below. Thanks guys for stopping by. See you on the next one. Peace.